What are functions of capillary? Capillary is responsible for exchange of solutes, such as O2 and CO2 solutes, and exchange of water, bulk water movement. What are the different pressures that control water exchange across capillary? There are two main pressures that control water exchange across capillary: hydrostatic pressure and osmotic pressure. What is hydrostatic pressure? Hydrostatic pressure is the force exerted by the blood confined within blood vessels or heart chambers. What is the difference between capillary and interstitial fluid hydrostatic pressure? While capillary hydrostatic pressure, CHP, is the pressure exerted by blood against the wall of a capillary. Interstitial fluid hydrostatic pressure is the pressure exerted by the fluid of the interstitium on external blood vessel. While capillary hydrostatic pressure is the principal force for capillary filtration, interstitial hydrostatic pressure opposes capillary filtration. While capillary hydrostatic pressure is 32 mm mercury at arterial end and it is 15 mm mercury at the venous end, interstitial hydrostatic pressure is close to zero. What are the factors that affect hydrostatic pressure in the capillary? Hydrostatic pressure depends on 1. Arterial and venous pressure, 2. Precapillary resistance, in the arterioles, and postcapillary resistance, in the venules and small veins. What is osmotic pressure? Osmotic pressure is determined by osmotic concentration gradients. Difference in the solute to water concentrations in the blood and tissue fluid. A region higher in solute concentration, and lower in water concentration, draws water across a semi-permeable membrane from a region higher in water concentration, and lower in solute concentration. What is the total osmotic pressure of plasma? And what are solutes in the plasma that contribute to osmotic pressure? Total osmotic pressure of plasma is 6,000 mm mercury. It reflects the presence of electrolytes, equal in concentration on both sides of the capillary. Plasma proteins, intravascular space. What is oncotic pressure? What is the importance of oncotic pressure? Oncotic pressure, or colloid osmotic pressure, is a form of osmotic pressure induced by proteins. Oncotic pressure is 25 mm mercury. Pulls fluid into the capillaries and/or prevents fluid from leaving, force reabsorption of water. What is net filtration pressure? It represents the interaction of the hydrostatic and osmotic pressures. Difference between the PC and the pi-P. Is NFP the same in arterial end, middle of capillary and venous end? No changes at different points in a capillary bed. At arterial end, there is filtration. At middle of the capillary, there is no filtration. At venous end, there is reabsorption. Remember Starling law. Starling hypothesis states that the fluid movement due to filtration across the wall of a capillary is dependent on the balance between the hydrostatic pressure gradient and the oncotic pressure gradient across the capillary. The four Starling's forces are: hydrostatic pressure in the capillary, PC; hydrostatic pressure in the interstitium, pi; oncotic pressure in the capillary, pi c; oncotic pressure in the interstitium, pi I. Net fluid flux is proportional to this net driving pressure. Additional factors need to be considered, which are filtration coefficient, Kf. If it is positive, this mean filtration. If it is negative, this mean absorption. What is the function of lymph? The lymphatic system is a scavenger system. Removes excess fluid, excess protein molecules, debris, and other matter from the tissue spaces. Lymph vessel walls automatically contract and pump the fluid into the blood circulation.